Reed switches. Okay. That's awesome down there. Really cool. So, you know, I can either run it in a magnetic coupling, I can spin this around, have the coil be over here, and have that one spin magnetically with this one, or I just have that coil running both of them at the same time. And it's all south facing out right now. Except up here, this is north out. Hello, everybody. Now I had a big gray coil over here. This coil right here. But I put this one in its place. One, because it doesn't have a magnetic core. I know that sounds oxymoron, even paradoxical, but this coil functions a lot better than that one does. In my opinion. They both function really well. Look at that. Look at how much momentum is in the neutron. Oh my God, that's tingly. That's awesome. That is so much speed right there. Maybe a little bit of vibration as well. I'm thinking the combination of the speed and the vibration is making it so it'll turn. And it looks like it's turning the opposite way that it's spinning. So that's another awesome. Coiling for. I started doing it because I was bored. I used to buy them. But that was just moving so fast that it started kind of rotating. That's awesome. Because that stator is fixed. That is not a rotating stator at all. And it just started kind of rotating. Hey, Yanni, what's up? I'm going to do that again. We're going to do it again just so I can prove that my eyes are not freaking playing games with me. So we start the power going through the system. put it up to 20. Wow, I'm like tingling. Now that's going to get going, and then the vibrations will lift it up off the table a little bit, and then the force of this pushing should make it go the other way. It's doing it. Oh my God, I can't feel. Wow, man, that is freaking powerful. That is awesome. Starts jumping off the table, and then when it's in the air, it's free to push. Oh wow, that's awesome. And there goes my induction coil. I'm gonna try and prop this up. It's probably not gonna succeed. I don't want to glue it onto the table. Yeah, it's gotta lean on something. Maybe like that. Try and put it in there like that in between the both of them. I don't know. If it works, it'll light the light. I don't think that's way too far away though. This is maglev. You can see it kind of bouncing there when I push down on it, and then it bounces back up a little bit. So cool. This one isn't though. Here, I'm going to turn it back around. We're going to work with the magnetic coupling. So this one's going to spin off the power, and this one is going to just spin off the magnetic. I knew that was coming. There. You got to get them like that. Okay, I'm going to leave that there. Now those should get going at, yeah, it is kind of. It's working on magnetic flux. See, it's actually pushing it away now. It's all right. I'm going to leave it down there. Hope it's okay. I'm just going to let them settle, because they don't want to stay where I want to put them. So I'm going to let them settle. Just as long as it's touching, I think it'll be all right. We'll turn it down to 9 volts. See, I don't think it's getting close enough now. Maybe. Now, are these mathematically optimal for coupling? I don't think so. Not at all. They're both 90 degrees, but one's an 8 inch and the other's a 6 inch. And I think they're actually in at like 5.5 inches, the magnets. So, 5.5 and 8 inches probably don't couple very well, but it manages to work based on just, speed, proper speed, I guess. I'm going to try and spin that one more time. Kind of getting into a rhythm maybe. But it is, obviously pushing it. It's just that it can always be so much better when it's not mathematically perfect. The sides equal up. Everything matches, the magnetism hits in the right spot at the right time. These things can get going like really fast. 120 works good. Because then it's 120 fits together pretty well. Thanks, Yanni. So that's magnetically coupled. And I just turned up the power. I think it's gonna stay in sync. Looks like it's syncing up. At least kind of. This one's magleved and the other one is not. So they're probably never really gonna sync up, but I think it's moving kind of in stride. This one's definitely moving faster, but the magnetic coupling. We're at 12 volts in, by the way. This motor up here is got 12 volt input. We're drawing 200 milliamps, and that's running that motor and this one down here. Through the transistor at the end of the table. You can barely see it, but it's down there. I might turn this around and see if we can get them going. can back it out, see if that'll help at all. Now see, like when they're syncing up, if they ever get that way, the vibrations will chill out a little bit. Yeah, I don't know, maybe not. I got another rotor to try, but I don't think it gets close enough. That's why I'm using the 8-inch. Oh, I see what we can do. I see. That is kind of feeling like it is syncing up though. That is pretty good. Oh, that's all right. I don't smell well either. All right, if that one keeps spinning, we're gonna call this good. 12 volts, 12.5 volts in, 210 milliamps. Huh, what can I do to make that better? I wonder. Yeah, it's stopping. That's all right though. I'm gonna turn it down like really low. See if we can't sync it up and, you know, eke it forward. Ah, yeah. All right. If you can see these, you probably can't see them. I'll get you off the tripod in a second. I'm just trying to get this synced up. I think it's might be going too fast. Let me spin this faster. Move that in. Haha, yeah. Okay, so my meter says that there's approximately between 4 volts and 7.5 volts, 8 volts going to that as it passes, you know, as power ends up in this cap bank. It's pretty much sucking it out as fast as it's going in right now. Look at it go, man. I think it's going. I mean the black one. That's the one we're trying to get moving. White one's moving pretty fast already. Yeah, I think we got it. Now this coil right here, this big one on the top, I call it my inductance experiment because we're experimenting with the diameter of the coil. So from the inner axle to the outer rim, I would say there's probably, I want to say around 250 layers, maybe more. And inductance is determined by layers, but of course, it's also determined by mass. So this half an inch isn't going to do. Maybe for a prototype or an experiment, but I think it works really well for how much energy it produces. All right, yeah, that's out of sync. Mm. Yeah, we might not be able to get that one in particular, but I have another one that might. Maybe no, it won't work. We could try 120 and 90 degrees combined, like have one be 120 and the other be 90. Ah. Oh yeah, man, I still get confused sometimes. Like knowing the difference between all that stuff and what you're talking about at a given time. You know, I still get lost. I am lost. You know, I don't know. But I think the south magnetism and the south magnetism have a pushing effect when coming into contact with two wheels coming into contact with one another. So this one goes this way and this one goes that way just because of the interaction of the south and the south. And it would go that way in the interaction between north and south as well. Except it's a little bit different. And I might set that up. Do like a north-south and see if we can get a better coupling that way. I don't think it'll work like that, but we could try. Yeah, it sounds like we're going to try that right now. So I'll turn that off. I love how smooth the Utron spins, man. It's like on there so easily. You can't really see the bottom part of it, but it's definitely. And then maybe I can even back it out a little bit. So I'm going to use the same rotor. I'm just going to flip the mags. Coming right along. 2 more to go. All right, it's another little north out. All right, let's give her some juice. From 9 volts. Kind of working a little bit, I think. I mean, maybe it's too early to tell. Yeah, I think that's working. I think at faster, like higher frequencies, it won't work as well with the traction phase, but I don't know anymore. I forget. 13 volts. Between 2 and 270. 200 and 240, in between 240 and 270. That's a better coupling. I think that's working better. Yeah, I think that's working a lot better. Hell yeah. So a traction phase for the win down there. Especially with the multi-sized rotors. Because you know that those magnets aren't hitting at the same rate. There's always one that's going to be skipping over somewhere because of how big a difference is. I mean, maybe if this one had 9 and that one had 4, it would work out. Since they both have 4 at exactly the same angles, the size needs to kind of be similar. For them to hit, at that magical spot. It's got to be a little bit. I hear some kind of friction. make sure that's on there. Maybe there is some static being generated here, considering these are made out of plastic. Not enough to be critical or anything, but it is definitely probably a factor. Wow, that is so mesmerizing looking at that spiral on the top of this thing. Even though it's so tight, you can see it. It's mesmerizing. I'm gonna get you off of there so you can see this. All right, Yanni. Cool. Yeah, and I got a whole like sculpture design based on this fundamental thing here, this mechanism of the one magnet either pushing or being attracted to the other and moving it, and then this one moving an additional one, and all being joined together by this very coupling from the center outward. All right, Yanni, I'll see you later, man. Thank you. Appreciate you, man. I'm really like good to see you. Wow, it is like moving itself into the other. That is amazing. So that's the north-south agreement there. I think it's going to move itself right into the center, and then it's going to stop. But are they linked up? I don't think it's. I think it needs to slow down a little bit. There's seven volts. I don't know. We'll see. Should I spin the other one and we see if it'll grip? No, I'm just trying to, right now I'm working with a small diameter disc and a big diameter disc, and I'm trying to get them to couple magnetically. Right now these are north and these are south facing out. As for any extracurricular activities this may be involved with, I can't say yet. Keep on thinking maybe if the big one was the one hooked up to the motor, that it might be working out differently. But I've had it actually working, so maybe if I turn this way and then move it in. So, I mean, look at how well that's running with how little power is going through this thing right now. It's 7 volts going in the front, and then it's about 2.5, 3 volts coming out. Well, probably more, 2.5, 4. And it's about 40 milliamps. Go the high route. So this motor is barely running, but the throughput to the next motor, getting a lot of action down there. And I had to remove 4 of the magnets in this rotor, so that's a 4 magnet rotor now, to make 2 4 magnet rotors to experiment with. I think that's a good coupling. I'm going to try increasing the power a little bit. Nine volts. All right, I'm going to go put this back. I just wanted you guys to be able to see the spiral on the top of that thing. It's pretty neat. The young in its various states can probably provide power to some stuff, but this is just it's an ornament. Too close, but it's working really well. It's just I'm afraid this cap is going to pop up and those magnets are just going to come together. So yeah, see, look at that. We need to get this farther side up here like this. There we go. It's got a frequency that is rather pleasing. And when you hold it upside down and you hit the bass, it's a way different tone. But you see, it doesn't ring. But you open it up like that. But yeah, I can definitely see how this can be interpreted in a lot of different ways. This one I do believe is almost like a doorbell. It's got a little hole so it can hang. And then see, now the whole thing is like doesn't ring. But if you hold it at the base and then give it a flick, you can definitely hear that ring. It's like an echo of the same sound over and over and over again, kind of building on itself and getting louder. Right? Like a tuning fork almost. But it is just a piece of metal. This one is anyway. I love it though. All right, let's see here. Why would somebody in the FBI be watching me? Bye. Oh. I think that's good. That's got to be good. Thank you, Yanni. Welcome back. So that apparatus down there is taking out as much power pretty much as this one is generating, which is about 7 to 8 volts with 11 going in from the start. So this takes about 3 volts to run. We're at 170 milliamps altogether. I think that's pretty damn good. Considering we're running 2 motors with the same power supply, basically. Awesome. For what? I would try mercury, but for what though? You talking about for like a wheel to spin like a Baccarat's wheel? Is that what you're talking about? They're lined up pretty good. I just don't want them to be sucked out, you know? Yes, but that's, yes, we're not gonna go there though. What can I do? Probably change those, at least half of those back to south. Let's try a north-south configuration and see if that holds. Because right now we only got about 10 minutes per attempt that it continues to spin, and then it unsyncs itself. And since we're not running a motor with this one, I think the north-south will actually be good for the coupling. And I spun it the other way. So now this is spinning this way, and this is spinning the opposing direction. I don't think that's going to work. It's working right now, but I don't. Spin it the right way, just for right now. We'll work with that later. Float on Mercury. Good Lord. I mean, yeah, no, I haven't tried any of that, but are you talking about magnetizing Mercury? We're trying to magnetically couple these two discs. One's running on a motor and the other one's just chilling there. It's all being powered by this pulse motor up here. I think that's a good coupling. Wow, that is working so well. You said it, not me. God, the retardation of America. Well, it wouldn't be if I didn't have stuff I needed to do, right? That is such a good coupling, man. And we got it. We got it. So north-south on the big disc and all of either one on the other disc will work just fine. That is brilliant. Yeah, and the cool thing about all these buttons on here is I don't need to put up with that stuff. If it's some sort of social ritual or something, that's BS, okay? Oh yeah, and there are some words that are just not allowed. All right, so we got a pulse motor up here on the table that is providing the energy for the pulse motor down there on the little table, and the two discs down here are magnetically coupled. That's what's going on down here. It's a learning experience. Those are two discs that are spinning each other through magnetically being coupled. And I would love to use some plasma to magnetically couple, because plasma has a strong magnetic field. It actually does have a great magnetic side to it. And I'm thinking that if I can do a bipolar neutron Tesla coil, split it in half, wrap it the way it's supposed to be wrapped, but then break it in half and point the two ends at each other, that would create a steady coupling, like an unbreakable bond. You know, if you do it right, right? And then there you go. You got a plasmatic propeller. You put you put two bipolar neutron Tesla coils, so you have four ends pointing out of the center. That's going to be your center. Then you have an outer toroid with however many you want on there. You spin the thing in the middle. It's gonna hook on to all those. It's not as hard as it sounds. It'll lift whatever you want it to. Hell yeah, man. Hell yeah. Yeah, Yanni, that's awesome. The more, yes, you teaching people that is the best, man. Thank you. Wow, I'm so happy with how this turned out. I just turned up the power a little bit. Thank you all. Thank you. Appreciate you. That Rue, right? Renison. All right. Oh my God, that is beautiful. But what I'm thinking, maybe nah. Wish I had, I do have these. So that white thing down there is this. You turn it that one way. Let me see if I can get it. And it's like a square. And then if you look at it from the top, it's a circle. So it's pretty sweet. And if you try and wrap something around this shape, you end up with what I think is called a Mobius strip, because it's not rounded, it's not squared altogether, but it's a combination of both. And it's a ribbon, it's a strip. You know, it's just something you wrap around the outside. And that is if its shape is maintained throughout the whole process of whatever you're experimenting with or on. Because if it's really a ribbon, then it's very pliable, you know, but it's not really a ribbon, it's just a material shaped like a ribbon, which would be very hard to move. The material I'm saying is like you wrap it around and it doesn't change shape once you get it completely encircled. That's awesome. We got it. We got it. Just had it up at like 15 volts. Turn it up to 20. See how much is coming out with 20 volts going in. 14, 15, 16. Oh wow, dude, those are going so fast. That is amazing. All right. And we're getting about, takes about 4 volts at 20 volts to run the upper motor. And then 16 or so volts come down here. And that's a lot of voltage for this little system. I think it's being held down as far as it can go too. It doesn't matter, it spins really well. Wow, dude. I mean, it's refreshingly original, but I mean, what the fuck was the point of saying that in the first place? Thank you, thank you. All right, I'll keep it going for a little bit longer. Usually I stop at about an hour. It's been about an hour, but Thank you, thank you. Really appreciate you guys. Thank you, sir. I really appreciate that. I do put a little bit of thought into what I do. I'm just not, I guess, the most organized person. And it's hurt me my whole life not being organized, but that's beside the point. I get along. I move along. I move forward regardless of not. I don't let that stop me from, changing it up. And if I was all organized, I wouldn't let that stop me from changing it up either. I've seen that get in a lot of people's ways. Just, oh, it doesn't work out on paper, so I'm not going to do it. Yeah, my pants are a little loose, but that's a good thing. That's since when is that a bad thing? So neat. That is coupled very well. All right, Dino. We're starting with a DC power supply from the wall. So there's your battery right here. And then we're running this pulse motor, so the energy goes into these coils, and then it goes through the coils to the transistor. The transistor is timed by this bifilar coil, and then there's no quick way to say it, but it's virtually, because down here, take the power from this one to run this one, and this one's magnetically coupled with this one. So, as for a nice clean package as to what it is, there isn't one. There's no purpose. I haven't devised a purpose, but I'm thinking to have some sort of lift is going to be the ultimate purpose. So what it is an experiment to see, magnetically coupled, whether we can get, there's a fan blades on this one, so if we can get, it to lift up at all, that would be awesome. Virtually, it's a pulse motor running another pulse motor that's running a magnetically coupled rotor. Nothing really too special, or I think it's cool. I'm not going to belittle what I'm working on, but yeah, man, it's pretty simple, actually. But all in all, it's actually a toy. It's something that I play with, experiment with. I can change it up any way I want to, basically. The only problem I have now is that more than half my stuff goes on a 1/4-inch shaft. This is a 10 millimeter shaft, so I got to build all new stuff to fit on the thicker shaft. Thank you, thank you. No, I don't mind explaining. It's just that when I do explain it, I get passionate about it. So, and this couldn't be working out better down here. These two discs are moving at exactly the same speed, and they're different sizes. So that's the awesome part. They're moving in sync right now. That is great. I'm going to give it a little bit more juice. 20 volts, 400 milliamps. Wow, dude. Yeah. So I was also thinking about, I have this unit over here that I'm working on too. It's magnetic suspension. So not maglev, but mag suspension. So it's got a long shaft, but suspended from these magnets right here. And I was thinking about adding a sphere to that magnet so that it's even touching less of the magnet. See, I have this magnetic sphere right here. And if I put that up there, it'll have even less friction than it has now. All right, I'm going to put this back in here so I can spin that. And we're going to time it kind of. Nothing real serious, but sorry, apologize. There we go. Okay. Now I'm going to give this a rip. There are two very powerful magnets on this either side that are like held back arrayed. So when the north out face comes to them, you got a traction like a V-gate for each side. Considering north is facing outward, it's like a V gate. When you spin it, let me think here. Yeah, this way, clockwise. So that's got bearings in it too. So it's spinning both types of ways. The wheel is spinning on the rod, and the rod is spinning on the magnet as well. So what I was thinking, based on these principles, I could add the sphere on this magnet train here, because it'd be easy to take it off. You know, just for the same reason that it would be less friction, because there's less surface area actually touching it. But that would be a really strong magnetic field there that this could dangle from and have even less friction than it has now. I think that would be really amazing. But I think what I think is really cool, based on this magnetic coupling experiment, it's basically an anode and a cathode, or the north and the south end of a magnet, that you would put the two ends of a bipolar Tesla coil facing in on each other and let those two breakouts for a DC couple with one another. I mean, it would be like a very strong connection, because it wouldn't bounce in and out of connectivity. It would remain connected. So I don't know. I'll do what I got to do to try and see for myself, um, those effects. Thank you, Yanni. But you know, it's virtually, you know, doing half, but you got to wrap it like you're wrapping it completely, but just have it so you can break it in half and have a little bit of length in your winding, so that it'll be able to separate and spread apart and face in on each other. I don't know, man. I feel like that would be epic, like epic, epic. Oh man. But I'm lacking in skill. I mean, I know Tinkercad pretty good, but I don't think Tinkercad can make a Tesla coil former. You know, not one of these formers. Yeah, I'm always thinking about ways to improve. See, now that's fun for, I didn't catch when we started, but for a few minutes, yeah, I would say. All right, so we're gonna flip it around. Now we're gonna see if we can't get some lift. I was apparently spinning it the wrong direction. Now I think those propeller blades are a little funky for lift. They're like they're more like cups for wind than they are wings. This is so cool. Thank you all for checking it out. I really appreciate you guys. Yeah, you can get it up to about 35 volts using nothing but a trigger strand, and that's at about 500 milliamps. So without the switch, I really can't get it too low. And I don't mind because I mean it's obviously in my mind the goal for that whole situation is unity or over unity. That's the goal of that situation, and I think for that situation you need 100 milliamps or less for your whole system. And see, if I take the second motor off and I just hook up a light to the output, I can turn it way up and the amps won't go up. Since I'm running another motor, the amount of amps that come through, it takes both the amps from that motor and this motor. So the amp draw goes up on whatever power supply you're using. 50 millimeter. Wow, dude. Hey, 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 hey. Eric, how's it going? Yeah, that's unfortunate. I'm not gonna, yeah. Yeah. See, now this coil right here is a bifilar coil, and it's triggering the whole thing basically. But since that motor isn't running right now, I'm drawing, let's turn it up to 20. $350 fewer milliamps than I would be if it was running. I'm just gonna unclip this for good measure. Oh, that's even better. Now we're down to 50 milliamps, 60. That's awesome. See, this is, but now it doesn't have a load on it at all, really. There we go. 50 volts in, 340 milliamps. $1,050 RPMs. $1,100. 55 volts in, 420 milliamps. Yeah, 11:21. That's so cool. Yeah, it still got stuck at 11:21. Doesn't matter where I put that coil, basically, in range. Uh, that's okay. It's okay. I've gotten it up to 1600 and something. Thank you, thank you. I mean, it is big and clunky, so I think that's really good for how big it is. But I can get a little one going really fast. I have 10 reed switches coming in the mail, like really good ones. Um, and some diodes. Let me show you what I'm working on. All right, so you got your dreidel or your top with your magnets on it. See, this is the part where, and then you want to couple it with your rotor. I'm going to need to solder a battery on there and a 2N2222 for each side. And then put the reed switches, that's only going to work like, well, actually, I can do it either way. But these little flat coils right here are trigger coils. So yeah, that should be pretty cool. Then I just need to solder the ends to the transistor and to the batteries that I got, which are little coin batteries. So right off the bat, I'm going to say they are magnetic. The batteries are magnetic. So putting them directly over the magnets aren't going to work. I got to put them in towards the center, and then it'll still spin. But if I put them in between the coils where I wanted to put them, they would prevent it from spinning because it's so magnetic. That's what the big problem with this rotor was. It's the magnetic pole of the 9-volt battery. But that's basically what goes in the center of one of my Utrons. It's got all the power and the switching that it needs to run in the center. Then you put the cap on. Put the cap on like so. Like that. Of course, it's got a bottom. It's like maglev. So actually, we might even be able to put it on there. I can show you that it's kind of the same concept as that rotor. Maybe there's even some juice left in the 9-volt battery. We'll see. So this is the base of the Utron. And it's maglev. Now I'm not going to put the cap on, but you kind of get the point, because this isn't built to the spec for the cap. This might not work. Let's try. Okay, so, and then this would spin independently of the rotor in the middle. It could counter rotate. See, it's got a lid. I'm going to make a different lid, one that you can kind of see through. It's going to have 12 spokes, and when you spin it really fast, you can kind of see through it. All right, cool, man. Thank you. Thanks for chilling. Thank you, Yanni. Yeah, I mean, like, watching things spin and watching those spinning things influence other things to spin, I think is like, it's almost magical. You know, like if you didn't have any idea what was going on with the magnets, you'd be like, what's going on here, you know? But I'm getting 10 of these ones coming in the mail. And they're really, really good. So I think that's going to work out just fine for at least those experiments. Thank you, Yanni. Thank you. See, it kind of wants to kind of rotate now. There's not enough juice left in the battery to really have any influence on the coils. So that's the other thing. I gotta put, I don't know if it's still chilling. Yeah, it is. Here it is. This, the 9-volt case holder thingy, I gotta put that on here so I can switch the 9 volts out without disrupting anything really. Because right now it's just glued on there and that's terrible. And it gets really hot too. I mean, right now those coils are so small. They're literally about, I want to say 35 or 40 turns around that bobbin that it's on, of 20 gauge. So that's a lot of current, that's a lot of heat. Thank you, thank you. Yes, please. And this is a polishing cloth for things like the unk. Where did I end up putting that? I don't know. I'll find it. And that'll be cool because everything to run this thing is on the inside. But I need to put 2 more coils on that. And maybe a diode or 2 will help it work right. Anyway, what I'm getting at is I need to get my soldering gun in action. I need to start soldering this stuff. Because there's no room to use clips, and just the things being twisted together like they are, they're going to come undone. So it leaves me with little option. All right, thank you very much. I'm gonna go for right now. Peace out, everybody. Have a wonderful day. Please subscribe. Peace out.